In this video, we want to find the integral from 1 to infinity of inverse tangent of square root of x dx. Let's first make a u substitution. We'll let u equal the square root of x. So du is 1/2 times square root of x dx. So to solve for dx, we multiply both sides by 2 root x. So we have 2 root x du is equal to dx. And then root x is u. So that's just 2u du is going to equal dx. So now we have the 2 factored outside. And then it's integral u inverse tangent of u du. We'll do integration by parts. We'll let f be inverse tangent. And then dg will be u du. So then the derivative of inverse tangent is 1 over 1 plus u squared du. And then g just will be u squared over 2. So now we multiply f and g and then subtract it by the integral of g df. So we'll factor out the 1/2 from the g. And to integrate this one, we'll add 1 and subtract 1. And now we can break this up into 2 separate fractions. The first fraction will have 1 plus u squared over 1 plus u squared. That's going to equal 1. And then minus 1 over 1 plus u squared. 1 over 1 plus u squared is just the inverse tangent of u. The antiderivative of 1 is u. And notice I did not change the limits from what we're given. Although technically, if you were to change the limits, you still have when x is 1, u is 1, and then when x approaches infinity, u also approaches infinity. So at this point, you could just go from 1 to infinity, but I chose to switch it back to root x and then go from there. Okay, so now we have, we substitute square root of x in for u, and then we have square root of x squared. That just becomes x, and then this negative 1/2 will distribute to both of these to get negative 1/2 root x plus 1/2 inverse tangent root x. Okay, now we're going to evaluate this from 1 to b, where b approaches infinity. So first let's plug in b, and actually what we did here is, before we plug in b, we separate this in 2 separate limits. So this is going to be the limit over here, and then this guy will be the limit over here. And the reason I broke it up is because I can easily find the limit of 1/2 inverse tangent root x. Because one thing you need to know about the inverse tangent, there's asymptotes at negative pi over 2 and pi over 2. And so as x approaches positive infinity, it's going to approach pi over 2. Okay, so now we plug in b, subtracting when we plug in 1. So now let's evaluate this. So we said as b approaches infinity, inverse tangent of root b approaches pi over 2. So this guy is pi over 2. Inverse tangent of 1 is just pi over 4. And now for this one, let's see. I chose not to evaluate this just yet, and instead just calculated these. Basically, whatever's in the box here, I calculated. So 1 and 2. And then this one, I just left it alone because I'm going to do some more math there. So again, inverse tangent of 1 is pi over 4, and then minus that by 1/2. So I simplified all of these to get negative 1/2. And then now I just need to evaluate this limit. Okay, notice I have a b here and a root b, so I'm going to factor out one of the root b's, and then over 2 because you have the halves here. So the square root of b over 2, and then what do I need to multiply that to get b over 2? Well, I need to multiply by the square root of b, and then over here it's minus 1. Now, I'm going to break this up into 2 separate limits. So this is using the product rule of limits. This limit right here is going to infinity, and this square root of b is going to infinity. Inverse tangent of 1 square root of b is going to pi over 2, and that's going to minus 1. So basically you have negative 1/2 plus infinity times pi over 2 minus 1. So the limit here will go to infinity. And so answering the question, what is the integral from 1 to infinity? Well, that's going to be infinity.